A fully operational light cruiser vanished from the ocean surface without a single survivor, while the heavily damaged enemy vessel that killed it produced more than 300 living witnesses. In November 1941, the Royal Australian Navy warship Sydney disappeared off the coast of Western Australia. 645 men were lost in a single day. The only official record of the engagement came from the surviving crew of a disguised German merchant raider. They claimed mutual destruction and described an opening blow that effectively severed Sydney's command. Without a hull to examine, those claims could not be tested against the steel. For 66 years, the location of the wreckage remained the greatest naval mystery in Australian history. The ocean swallowed the cruiser completely. No distress call was ever confirmed in the official logs of coastal stations. No debris field was systematically surveyed or mapped in the immediate aftermath. What first proved that a catastrophic battle had occurred was the stream of German survivors recovered over the following days and their subsequent interrogations, alongside the few Australian relics later found at sea, including a battered Carley life float and a naval pattern lifebelt. Their logs detailed a devastating point-blank gunnery exchange that left both vessels burning uncontrollably. The German ship ultimately sank after its crew evacuated in good order. Sydney, according to the enemy accounts, drifted away over the horizon, ablaze and sinking. The sheer scale of the Indian Ocean and the absence of a precise starting coordinate created a search boundary that was effectively unbreakable. You cannot survey an abyss based on a horizon line described by men sitting in lifeboats. The sea scattered the few surface clues quickly, and in 1941 there was no practical way to record or replay an acoustic trail the way modern sonar surveys can. Dozens of acoustic sweeps and coastal visual searches over the decades found nothing because the target was too small and the grid was too vast. The cruiser's physical state remained unknown, so every theory about how an advanced warship could suffer total crew loss against a converted merchant vessel remained a model without forensic backing. What was known was that a violent engagement did occur and that the enemy ship definitively rested somewhere on the seafloor in the same general quadrant. German testimony still gave investigators a rough bearing and estimated timeline, and the weather and wind conditions recorded as their own ship went down. That meant a large debris field still existed somewhere in the dark, just not Sydney's. The ocean currents had carried the German lifeboats for days before they were intercepted. By reverse engineering their surface drift patterns, oceanographers could theoretically isolate a much smaller search box. The search teams realized that looking directly for the Australian cruiser was the wrong mathematical approach. Sydney had drifted away from the battle space before finally going down, which made its resting place a moving variable. And Kormoran, by contrast, had been scuttled near the action itself. It offered the fixed point on the seabed the search mathematics needed. To break the 66-year silence and find the cruiser, they had to stop looking for it. The only way to solve the greatest disappearance in Australian naval history was to first find the enemy that killed it. 8,097 feet, about 2,500 meters below the surface of the Indian Ocean, ambient pressure will crush unprotected air-filled housings and fragile components, the kind of failures that can implode casings and shatter glass viewports. There is no ambient sunlight and temperatures hover just above freezing. This is an environment completely hostile to human intervention, and that extreme depth forms the first impenetrable barrier around the missing Australian warship. It ensures that the remains of the vessel and its crew are shielded from casual interference. Even reaching the seabed requires winches containing miles of reinforced telemetry cable and heavy-duty deployment systems capable of handling massive dynamic loads during the long transit through the water column. But physical depth is only the secondary layer of protection surrounding this site. The primary barrier is legal. After the wrecks were found, the Australian government declared them protected historic shipwrecks and established protected zones around them, creating a permanent and heavily enforced exclusion regime. It completely redefines the parameters of a marine salvage operation. In a standard commercial salvage, the objective is to physically interact with the sunken asset. Engineers plan to attach lifting bags or rig heavy cables to bring components back to the surface for structural analysis. Commercial operators often cut away tangled debris or penetrate sealed interior compartments to extract valuable materials or specific forensic evidence. Within the protected zones, intrusive interference and the removal of relics are offenses without a permit, and the non-disturbance parameters applied to these sites prohibit physical salvage and forbid recovering objects. The operation is therefore reduced to a non-contact survey mission: look, map, film, and leave everything in place. This dual barrier of crushing oceanic depth and zero-tolerance maritime law forces a radical shift in operational strategy. Every piece of sensor equipment lowered into the abyss must be carefully calibrated to avoid accidental collision with the fragile steel structures below. If a remotely operated vehicle becomes entangled in the wreckage, the recovery options are severely limited. The operators cannot simply pull the tether free, if doing so risks dragging pieces of the war grave along with it. They must maneuver with perfect precision. The legal mandate dictates that the sanctity of the wreck supersedes any data collection objective. The survey team is obligated to document the condition of the hull and the surrounding seabed without altering a single structural component or displacing a single piece of sediment. This strict adherence to the law ensures that the site remains a pristine historical record of the 1941 engagement. The mission is observational from start to finish. Search directors must answer decades of historical and naval questions with mapping and visual documentation alone, never a laboratory sample. The entire forensic case has to travel up through miles of fiber optic cable, which creates an unforgiving methodological problem. How do you prove a violent sequence of destruction when the law forbids you to handle the evidence directly? Sydney was still the wrong target to search for first. The currents had long since scattered whatever surface evidence remained, so in mid-March 2008, the team anchored the problem to a fixed coordinate and executed a massive operation of data-driven backtracking. On March 12, 2008, the search team located Kormoran exactly where the reverse drift models predicted. Thus, that find anchored the problem to a real patch of ocean and marked the critical breakthrough. It transformed a theoretical search grid into a localized tactical theater. With Kormoran now fixed on the seabed, the team could cross-reference the enemy logs describing the Australian cruiser limping away ablaze. The German officers had recorded the burning ship's final heading and estimated speed as it disappeared from view. Applying that trajectory to the confirmed datum, the engineers projected a highly confined probability box. They were no longer searching the vast expanse of the Indian Ocean. They now had a narrow mathematical lane to sweep, and the survey vessel towed deep-water side-scan sonar through it. The two sonar towfish units, the SM30 for wide area coverage and the AMS60 for higher resolution, stitched the seabed into an image where man-made geometry stood out from rock and silt. Sending low-frequency acoustic pulses through more than 1.5 miles of water requires immense power and precision. The sound waves travel down to the seabed, strike the bottom, and bounce back to the surface receivers. The timing of those returning echoes paints a topographic map of the ocean floor. The ship mowed the lawn back and forth across the calculated trajectory, casting a wide acoustic net over the pitch-black terrain. Natural geological formations return soft or scattered acoustic signatures. Man-made structures cast sharp, distinct geometric shadows. The multi-beam sonar was hunting for hard metallic returns that broke the natural pattern of the seabed. Within days, the acoustic sweeps registered a massive anomaly. The sonar painted a distinct, heavy concentration of debris and a primary hull structure resting upright in the silt. The dimensions of the acoustic shadow matched the length and beam of a Leander-class light cruiser. The geometry was correct and the location perfectly aligned with the forensic hindcasting models. The sonar data provided an enormous positive knowledge gain. It proved the target was exactly where the mathematics said it should be. The search team had successfully acquired the target without ever disturbing the debris field, but acoustic target acquisition has a hard physical ceiling. Sound waves can map the outline of a sunken hull and determine its overall orientation on the bottom. They can measure the length of a localized debris field. However, they lack the granular resolution required to conduct a forensic autopsy on a damaged warship. A multi-beam echo sounder cannot distinguish between a crushed bulkhead and an intact armor belt. It cannot see the jagged edges of a torpedo blast or the specific entry wound of an artillery shell. The acoustic data confirmed that a massive warship was down, but it offered zero answers regarding why the vessel succumbed so quickly or why no lifeboats were ever launched. The sonar shadow was only a silhouette. To prove the identity of the ship and unmask the mechanics of its violent end, the operation had to abandon the acoustic net. They had to send cameras into the abyss and cross the absolute optical threshold. When thousands of tons of flooded steel lose buoyancy, the descent to the ocean floor is not a gentle drift. The plunge to the seabed generates immense structural shear forces. As a compromised warship accelerates downward through the water column, the fluid dynamics strip away weakened components. To document this violent mechanical sequence, the survey operators transitioned from acoustic sweeps to high-definition video. They deployed heavy work-class, remotely operated vehicles into the black water. These robotic platforms carried powerful lighting arrays and broadcast-quality cameras down into the abyss. Their lights pierced the darkness and illuminated a scene of catastrophic structural failure. The optical survey immediately located the forward section of the Australian cruiser. The entire bow had been violently severed from the main hull. It was found resting upside down on the seabed hundreds of meters away from the rest of the wreckage. The cameras documented the jagged tearing of the heavy steel plating. This massive spatial gap between the two primary pieces of the warship confirmed a brutal sequence of destruction. During the 1941 engagement, a German torpedo struck the port bow with damage evidence pointing to a detonation in the vicinity of frame 25, around the Type 125 sonar dome. This initial blast severely compromised the structural integrity of the forward frames, but it did not immediately snap the keel. The vessel continued to sail blindly as the fires raged and the forward compartment slowly flooded with seawater. The actual severing of the hull occurred during the final plunge. This is the mechanism of hydrodynamic bow separation. As the immense weight of the flooding pulled the nose of the ship under the surface, the relatively intact buoyancy of the aft section resisted the downward pull. Once the cruiser slipped entirely beneath the waves, gravity and water resistance took over. The velocity of a massive steel object falling through over a mile of water creates extreme drag. The weakened hull simply could not withstand the opposing forces of the heavy sinking bow and the drag on the superstructure. It is highly unlikely that the bow detached while the ship was still floating, and the separation most likely occurred during the sinking process as the wreck moved down through the water column. The flooded bow broke away and fell independently. With the heavy forward section removed, the hydrodynamics of the falling wreckage shifted radically. The center of gravity for the remaining bulk of the ship moved aft. The main hull tumbled through the darkness and ultimately slammed into the seabed stern first. The kinetic energy of this impact was staggering. The stern drove deep into the heavy bottom sediment while the momentum caused the upper decks to collapse downward upon themselves. The remotely operated vehicles spent days carefully navigating the debris field, mapping the twisted wreckage that spanned the distance between the severed bow and the crushed aft section. They recorded torn fittings, displaced structures, scattered debris, and pulverized bulkheads, while the main guns and many heavy items remained largely in place. Exterior mapping finally exposed the physics of the sinking in concrete visual terms. However, this visual documentation also defined a permanent forensic ceiling. The survey was legally and practically bound to the exterior of the wreckage. The cameras could record the exterior blast damage and the torn edges of the shear zone, but they could never cross the threshold into the internal spaces. The strict non-contact mandate of the legal exclusion zone meant no debris could be moved to clear a pathway. Furthermore, navigating a tethered robot into the collapsed, lightless corridors of a heavily damaged warship carries a massive risk of entanglement. If the tether snags on a jagged piece of steel, the vehicle is permanently lost. Therefore, the absolute inability to penetrate the sealed interior compartments means the exact internal flooding progression can never be mapped. The investigators cannot measure the internal explosive overpressure or inspect the lower decks for damage control efforts. The exterior optics proved the mechanics of the final plunge. The torn bow and the stern-first impact perfectly explain how the vessel physically reached the bottom, but structural failure alone does not account for the total absence of survivors. An intact stern section would theoretically allow a disciplined crew time to deploy emergency rafts before the vessel slipped beneath the surface. The shredded hull explains the sinking, but it completely fails to explain why the Australian sailors never launched their lifeboats. It fails to explain why the main battery turrets never fired a coordinated salvo in self-defense. The hydrodynamic separation was simply the final physical result of the battle. To understand why the ship was completely paralyzed long before the hull snapped, the cameras had to move up the wreckage and examine the highest point of the command superstructure. For over 6 decades, the historical accounts of the German survivors presented a stark contradiction against the theoretical resilience of a modern warship. How could an advanced cruiser fail to coordinate a counterattack or launch a single lifeboat before plunging into the depths? The robotic cameras had already mapped the violent structural failure of the hull. But the answer to the total loss of the crew was not found in the severed steel below. To test that final claim, the operators flew the camera sleds upward from the wreckage below and focused their lights on the highest remaining point of the command superstructure. There, in the crushing blackness, they found the physical proof the survivor accounts had always demanded. The German raider had disguised itself perfectly and waited until the Australian vessel closed to a highly vulnerable distance before dropping its false flags and opening fire. To understand why the cruiser never recovered from that opening salvo, the cameras meticulously scanned the primary bridge. As the high-definition feeds reached the surface vessels, the engineers identified a distinct penetration through the heavy steel plating of the compass platform. Its size is consistent with a 15-centimeter shell, the caliber carried by Kormoran, and it strongly supports an early disabling hit to the bridge. This is what naval analysts call a decapitation hit. A direct strike into the bridge area can shatter ship control, kill or incapacitate key officers, and sever the communications that hold damage control together. Even if engines keep turning and steel stays afloat for a time, a ship can become operationally blind and leaderless, a crew trapped in heat, smoke, and chaos without a coherent order to fight or abandon ship. Capturing this imagery was a major forensic step, but it still left the interior story partially sealed. Even so, the bridge area penetration and the wider damage pattern strongly support the German account of a rapid disabling opening salvo, while leaving questions of internal progression, timing, and individual survival paths beyond definitive proof. With the key objectives met, the mission could shift from search and confirmation to long-term permit-controlled stewardship of a protected heritage site. The operational window to map the battlefield permanently closed the moment the final tethered robot was secured to the surface deck. With the cameras out of the water, the immediate forensic mission was terminated. The expedition did not linger over the site. The final objective was to turn the acoustic and optical hull into a definitive map of the 1941 engagement. By plotting the exact coordinates of both Sydney and Kormoran, the engineers fixed the true geometry of the battle. The opening salvos were exchanged at extremely close range, the two crippled ships drifted apart as they lost buoyancy, and the primary wreck sites now lie about 12 nautical miles apart in roughly 2,500 meters of water. That measurement closed the last great void on the chart and finally gave the families of the lost crew a fixed coordinate for the tragedy. But this cartographic success also reinforces a severe physical reality regarding the future of the wreckage. The deep ocean is an unforgiving environment for ruined steel. Depth may isolate the wreck from casual interference, but it also guarantees continual material failure as marine bacteria and slow galvanic corrosion consume the armored bulkheads and shattered framing. Because the exclusion zone forbids intervention, no one can lower stabilizing anodes, brace torn plating, or physically support the structure. The wreck is therefore a slowly collapsing monument. Over time, the heavy turrets will fall through weakening decks. The remaining superstructure will fold inward, and the ship will sink further into the sediment beyond preservation in its present form. The expedition leaders understood this unavoidable deterioration. Their mandate was never to save the steel. Their singular objective was to extract the truth before the ocean completely erased the evidence. By achieving a flawless non-contact survey, they secured the historical record without violating the sanctity of the mass grave. The surface vessels powered down their sonar arrays and retracted their heavy winches. They left the deep seabed exactly as they had found it days earlier. No artifacts were brought aboard, and no physical markers were anchored to the wreckage. The only thing they took from the ocean was digital data. Today, the site remains permanently protected by law and managed through controlled access, protected zones, and permit conditions. The exact coordinates are restricted, and any approach, commercial or private, is treated as an underwater cultural heritage compliance matter. The operation showed that disciplined, non-contact robotics could solve a battlefield this deep. Sydney was found, and its final destruction was brought into alignment with the wartime record. The case is officially closed. The boundary of the unknown was breached just long enough to illuminate the truth, and then the darkness was allowed to return.